Hi everyone, today I'll be talking about lesson 8.4, which is adding and subtracting rational expressions. Remember that a rational expression is an expression that is a ratio or a fraction, and the top and bottom can both be polynomials. Because we are dealing with fractions, fraction rules apply. So if we want to add or subtract fractions with like denominators, remember that the denominator stays the same and we just add or subtract across. So let's do a quick little example. If I have 1/5 plus 2/5, this would equal 3/5 because the denominator, which is the same, stays the same. And the top is what we are going to add or subtract. In this case, add, since we see a plus sign. We are going to apply those same rules to our rational expressions. If we have the same denominator, we can add or subtract. If not, we have to create like denominators. So let's take a look at this first one. If I have 2x over x plus 6 plus 5 over x plus 6, notice that this x plus 6, the denominator is the same. And so since we have like denominators, that denominator comes across, and we just simply add 2x plus 5, and that's our answer. When we don't have like denominators, we are going to have to use some least common multiples in order to find our lowest common denominator. And so let's practice just working with least common multiples first. So in order to do a least common multiple, we want to do what they have in common. And for those of you that are not using color, I'm also going to underline what they have in common with a squiggly pen, squiggly line. And then we're going to multiply that by everything else, the stuff that they don't have in common. And I'll designate that by double underlining it so that you can tell what that is. All right, so let's go ahead and take a look at a couple of expressions. The first thing that we want to do is break these expressions apart and kind of factor them out so that we can see what they have in common. So 9x to the third could be rewritten as 3 times 3 and then times 3 x's. 3x squared minus 21x, I see a common factor, a greatest common factor of 3x, and I'll have an x minus 7. What do these have in common? I see a 3 here, and I see an x. So they have a 3x in common. What do they not have in common? This extra 3 does not appear in the second one. These extra x's do not. And then x minus 7 does not appear in the first one. So in order to write our least common multiple, we take what they have in common, which is a 3 and an x, and I'll underline that in green. And then we want to multiply by everything else. So another 3, a couple more x's, and an x minus 7. So all of these things, the 3, the x's, and the x minus 7 are what they did not have in common before. Let's simplify this a little bit. I could write this as, let's see, I have a coefficient of 3 and another coefficient of 3, so that'll give me 9. I have 1, 2, 3 x's multiplied together, so that'll be an x to the third, and then in parentheses x minus 7. And so this is our simplified form of our least common multiple. Let's try it with a couple of quadratic expressions now. And with quadratic expressions, you're only going to know if they have something in common if you factor it and they have a factor in common. So this will factor to x plus 3 and x plus 2. The second one will factor to x minus 6 and x plus 3. So let's first state what they have in common. I see an x plus 3 in both locations. What do they not have in common? This x plus 2 only occurs in the first one, x minus 6 only occurs in the second one. So let's first state what they have in common. X plus 3 is what they have in common. And I'll underline that in my squiggly, and then state the things that they do not have in common, which is x plus 2 and an x minus 6. And so those are my double underlined. Because this is already factored, it is in its most simplified form. So we can go ahead and box this as a final answer.